Hello, everyone. This is the lecture for section 1.7 for our Math 210S portion of the course, inverse functions. Oh my God, no, good Lord. Hello, everyone. This is the lecture for section 1.7 for our Math 210S portion of the course, inverse functions. So, in this section, what we're going to cover is something that's really nice to have when looking at mathematical formulas and mathematical functions. Um, Suppose you had a function f of x. Okay, it would be really nice to have another function that undoes what f of x does. Okay, and that function is what we call an inverse function. Okay, so essentially, an inverse function is a function that undoes something that another one does. Okay. In this section, we're going to cover the definition of it, some smaller little things for it, and in particular, how to find an inverse function. Okay. All right. So the first thing I want to do, right, is do this definition first. Hopefully, I think this is something I defined at the very beginning of the class. A one-to-one function is a function where each output has exactly one input. Okay. This is different from the definition of a function where each input had exactly one output. Okay. So it turns out if you have a function that is one-to-one, okay, then it must have an inverse. That's what this theorem is saying down here. Okay. The second that you have a one-to-one function, okay, you have something that must have an inverse, okay? And an inverse, the definition for an inverse, okay, is this right here, okay? And I haven't finished it in particular because I kind of want to use the composition notation. So if you remember the composition notation, right, this can be rewritten as f compose f inverse of x. This has got to be x. And then the same thing, this, right? If you guys remember the composition notation for this one, right? This is f inverse composed f of x. There we go. This has got to be true. In order for you to have an inverse, this is what ends up happening, okay? So, and if you take a look at it, right? If you take a look at both of these that are on the left-hand side, right? What this is saying is basically I can plug an x value into my inverse and then plug it into f, and I get x back. And the same thing can be said with the other order. I can grab an x value, plug it into my function, grab that output, put it into my inverse, and I get my value x back, right? Essentially what this is saying is if f of x does something, right, then f inverse undoes it. Okay? All right. One real, this is just I know this is going to sound confusing, but in terms of the notation, I haven't formally shown anybody yet, right? You see that to the -1 that denotes an inverse, right? That does not mean this, and we're going to get here eventually, just not yet. Okay. Uh, when we get to the exponential section where we cover exponential functions and exponential notation, this is going to be something that we'll see. They don't mean the same thing. So just, I know some of you have maybe taken pre-calculus before. Don't confuse them. Okay. Just giving everybody a fair warning. Okay. We'll hash it out during the class while we run through it. Okay. All right. So I've got a couple of examples here. Okay. So let's take a look at this first one, just so we can understand what the heck an inverse does, right? So if we take a look at f of x equal 2x, right? Okay, we can see that if we plug in 3 for f of x, right, then our y value should be 6, right? Because the function is telling us to do, whatever the input is, multiply it by 2, right? Okay. Whoa, not what I wanted to happen. Sorry. There we are. Okay, we're back in business. Okay. So then if we want to do the inverse, right, what ends up happening is this. We're going to give this thing the 6, which was the output from the original, right? And the idea is if we give it 6, we need to get 3 back. Because that's what the inverse does, right? Hopefully you think through this really quick, right? So if you take a look at the function itself, the original function grabbed our x value, multiplied it by 2, right? So then that means that our inverse has got to do the opposite. It's got to divide by 2. And it turns out x over 2 is the inverse. Got it? Making sense? Okay. So let's try another one. Okay. Let's try the one that follows, the one right below. Okay. Let's say f of x is x divided by 3, right? So and that means if I give this thing 12, the output should be 4, because that's what f of x does, right? It grabs my x value, whatever it is, and divides it by 3. My output should be 4, which means that my inverse should do the opposite. If I give this thing 4, it should give me back 12, right? So that's what the inverse does, correct? If we go back to the statement of f of x, right, you see that it's grabbing an x value, dividing it by 3. It needs to do the opposite. Our inverse needs to do the opposite, right? And it turns out, right, the inverse for f of x is 3x. It does the opposite, right? Awesome. Okay. Let's move on to the next one. I'm just getting a used to whatever an inverse is supposed to do, right? Let's take the square root of x. Okay, same thing, right? Let's go ahead and take 16, right? If we give f of x 16, right, then it's going to take the square root. It should give us back 4. Okay. The inverse should do the opposite. If we give it 4, it should spit out 16. Right? So if you take a look at the definition of the f of x, right, of our function, what this thing is doing is it's grabbing our input, it's grabbing our 16, and taking the square root. That's how we get our 4. So what we want is for our inverse. What we want for our inverse, okay, is for it to do the opposite. That we give it 4 and it gives us 16. And it's got to be some opposite operation of the square root. And lo and behold, right, x squared. That does it. And it does it for all the x's, right? Okay. Boom. Moving on. So this last one, the square root of x, it's a little funky, okay? And I'll cover it in class when we get there, okay? But for now, it does what we need it to do, right? Next one down, x cubed, okay? Again, right? If I give it an x value, let's say 2, right? It should give me the output, right? It'll give me the output of 8. 2 to the third power means 2 times 2 times 2, and that's 8. Which means the inverse has got to do the opposite. If I give it 8, it should give me 2. Okay? Okay. Since the original cubed whatever I gave it, right? The inverse has got to undo that. The thing there is the cubed root, if you guys have ever worked with that. Cube root of x. Okay? All right. Let's keep going. Last one. This one's the funky one. This is another funky one, right? Let's take the absolute value. So the thing behind an absolute value is whatever number's inside, it should turn it positive. That's it. Okay? And it should do it for everything. So let's go ahead and take -2. So let's say I grabbed -2, gave it to f of x, to the absolute value, right? It should spit 2 back, right? Cool. So that means my inverse, if I give it 2, it should give me -2. Basically the swap of this one, right? Okay. This one does not exist. There is no inverse for that, okay? And in particular, it's because it is not one-to-one, right? Okay? Not all functions have inverses, okay? Not all functions have inverses. The ones that do, right, we should be able to figure out. This is what we're going to cover for the rest of the section, okay? One, if we have two functions, right, how do we determine if they are inverses? And if we just have one function, right, how can we find the inverse? Okay? All right, so let's move on to our first example. How do we determine if there are two functions that are inverses of each other, right? Okay? To determine if two functions are inverses of each other, right? Both of these have to be true. Both of these. So look at the combination, right? The composition of the two functions, right? Both of these have to be equal to x, okay? It suffices, at least for our level of math that we're in right now, right? It suffices just to show one of them, okay? Sometimes one is easier than the other, okay? So as an example, let's say I had these two. Let's say this is my f of x and this is my g of x, and I wanted to find out if they were inverses of each other or not, right? I can choose either one. I can grab f and stick it into g, or I can grab g, stick it into f. If either one of those produces an x, that is enough. That is enough for us to show that f and g are indeed inverses of each other, okay? Just for kicks and giggles, I'm going to do both, okay? So the first one I'm going to do is f compose g of x, right? If you remember the notation, that is f of g of x, right? So I need to grab all of g and stick it into f, okay? Uh, 1 over, well, let me actually do the notation that I was doing back then. So it's going to be f of 1 over x minus 2, which is the same thing as 1 over x minus 2 plus 2. And if you do this right, you guys hopefully see this on the bottom, the plus 2 minus 2 cancel. 1 over x, and that is equal to x. Like I said, this suffices. This is enough. This is enough to show us that f and g are indeed inverses of each other. Okay? Now, let me do the other one, right? Let me do g compose f. Okay? This is a g of f of x. G of f, so 1 over x plus 2. 1 over, whoops, 1 over x plus 2, whoops, messed that one up too. Okay. 1 over 1 over x plus 2 minus 2. Give you guys a second to look that in, okay? If you do this portion, x plus 2 minus 2, and you guys see how the minus 2 and plus 2 cancel? This is equal to x. Bam. We're all done. So these two, like I said, it suffices to show either one of these. So either this is equal to x or this one is equal to x. If you can get either one of those equal to x, you proved that f and g are indeed inverses. Okay? Okay. And I don't know why my page has moved. That is annoying. Hold the phone. All right, there we go. Okay, what comes up next is a couple quick checks, okay? I'll have you guys look at whether or not these are inverses of each other. Domain and ranges of inverse functions, okay? So if you remember what a domain is and what a range is for a function, right? The domain of a function is all the possible x values we can plug in, okay? And the range of a function f of x is all the possible outputs. Yeah? So now the idea here is, well, what does that mean in terms of f inverses? We know that the f inverse has to grab everything that f does and undo it, right? But what does that mean? Okay? The definition is right there in the little box, okay? That the range of a function f of x is the domain of the inverse function f of x, and then the domain of f of x is the range of f inverse. That sounds complicated as heck, right? It's much easier if we can draw the picture, just like we did in the first or second week of class, right? Let's go ahead and draw two little eggs here, right? We know that I can grab a dot, right? If this was my x values, right, then that means this side is going to be my domain, right? And we know back from first or second week of class, right, that if we hit this thing with f, we hit it with the function f, right, it'll take me to my y value, right, which is f of x. This is how functions work, right? If I had a x value, right, I can place it inside of a function f, right, and it will give me a y value. Simple enough, right? Okay. We know that the collection on the right, that is the range of my function f of x, okay? And let me actually denote some, let me add a couple more. Come on, come on. My eraser on my tablet, there we go. Range of f. So we know that we can grab an x value, right? Give it to our function f, and it'll produce a y value, right? Now, remember what I've been saying about an inverse function, right? It's supposed to grab everything f does and undo it. So that means I should be able to bring this back over here, right? This is what f inverse should do, right? Okay, which brings up the definition that's above it, right? The values that f inverse is going to choose from are on the right-hand side of the picture here, right? And the outputs for f inverse are on the left-hand side. So this becomes There we go. That's the picture. I dropped my pencil. God darn it. There you are. Okay. Making a little more sense, making a little more sense. Okay. The last thing I kind of want to show you all is how to algebraically find the inverse of a function f of x, okay? So in many cases, not all, but in many cases, if I give you a function, it'd be nice to be able to figure out what its inverse is, okay? That's what I'm going to show you here now. There are ways to find an inverse for a function, okay, algebraically. Okay, so let's take, as an example, right, let's take this f of x function right here, okay? There are 3 steps, 1, 2, 3. First of all, we have to make sure that f of x is 1-to-1, okay? And if you remember from the first week of class, something that is 1-to-1 means it passes the horizontal line test, okay? So, I mean, I'm not going to give you something that won't pass the horizontal line test. So just keep that in mind, right? So let's move on to number 2 and number 3. Those are the 2 harder steps to take care of when we do this, right? Okay. So step number 2, right? It says solve for x. I'm going to turn this into y is equal to 2 over x minus 3 plus 4. And I'm going to resolve all of this and get x all by itself. You can do this however you need to, however you think you can, okay? But the idea is I want to get x by itself. Got it? Okay. So I'm going to rewrite it really quick. Y is equal to 2 over x minus 3 plus 4. Okay. I need to get my x by itself, right? Okay. I'm going to minus 4 on both sides. I get left with this, right? Y minus 4 is equal to 2 over x minus 3. I can grab anything I want and put it over 1. Okay? From here, I can do a cross multiply. Got it? So then I get left with this. Y minus 4 x minus 3 is equal to 2. Okay? I can go ahead and I'm going to do it in my hot pink here. There we go. I can divide away y minus 4. So and if I do this, right, I have to do it to the other side. So I'm going to divide that over here too, y minus 4. Okay? But this cancels that. So I get left with, I'm going to carry my work up over here, x minus 3 is equal to 2 divided by y minus 4. And then, like I said, I want x by itself, right? And that negative 3 is in the way. So plus 3 on this side. X is equal to 2 over y minus 4 plus 3. Okay, that takes care of this right here is the end of step 2. Now, let's scroll back up really quick. Step 3 is interchange x and y once you're done with 2. So if we can grab these 2 things, we can just grab these, the x and the y, and just flip them. So 2 over x minus 4 plus 3. Okay, and this right here is my f inverse. We are done. So that means Okay, that means that if I grab this function that I just found, right, and I do the composition of this with my original function, okay, then I will get x back, aka, okay, if f of x does anything, f inverse, the highlighted in green, will undo it. Okay. Okay. After that, I've got one more quick check. These are going to be pretty involved, so I'm going to give you guys a fair amount of time to do them with. Okay. And after that, lecture questions. This is a short section. Okay. Don't let that. Uh, it's a beefy section, so take your time with it. Okay. If there's any questions with it, ask me during our quick check time. Come downstairs to the tutoring center, or come to my office hours. Okay. All right. Besides that, happy studying.